This is a presentation on evaluating the value of IT investment. In the past few decades, there has been a large increase of available information systems and technology. Although these systems have substantially improved the efficiency of many organizations, they are not always perfect. Recently, there has been a widespread failure of many information technology products, resulting in $1 million in lost revenue. With the future of a company dependent on the success or failure of an IT investment, it is crucial to first assess the business value of IT. In the past, the process of such an evaluation has mostly consisted of speculation. In this presentation, however, we will discuss a new method of evaluation based on objective data and statistical analysis. One information system that has been credited with improving quality, efficiency, and safety is the Veterans Health Information Systems and Technology Architecture, commonly known as VISTA. VISTA is the health information system used by the United States Veterans Affairs Medical System. First created in 1968, VISTA is based around the electronic health record and is used by the VA in 163 hospitals, 800 clinics, and 135 nursing homes to connect patient health records. As the single largest medical system in the U.S., the VA provides care for 4 million veterans, and consequently, VISTA is one of the most widely used EHRs in the world. The data we will use today to calculate the business value of IT was obtained from the Department of Veterans Affairs on October 16, 2007. As seen in this chart, we will be using the budget of the Office of Information as a measurement for IT investment, as well as the number of records in VISTA and the VHA cost per patient index dating from the year 1998 to 2004. To more clearly analyze the correlation between the data, we must produce a scatter plot and establish a best fit line. Often, businesses make the assumption that increased investment in IT leads to an increase in use, which consequently increases revenue or savings. However, this assumption may not be correct if first there is an increase in usage, which increases productivity and thus increases available funds for IT investment. By creating data plots of the information provided by the VA, we can find the correlation between two variables, and later we will use the correlation values to calculate causality. First, however, we must ensure that there is a correlation between IT investment and productivity. To do this, we will examine a plot of IT budget versus cost per patient. As seen in this plot, an R-squared value of 0.7963 is provided. However, because correlation is denoted by the variable R, we must find the square root of 0.963, which is 0.89, indicating a fairly strong linear relationship. We repeated the process to find a correlation between IT budget and use of 0.76. And we also repeated the process to find a correlation of 0.56 between use and cost per patient. Then, we placed the correlation data into a table to help facilitate the calculation process to follow. Although we have found that there is a correlation between investment and productivity, we must next find out if IT investment preceded the improved productivity. To do this, we will use the equation above and the correlation values we found earlier. Whichever calculated value is closer to 0 indicates a cause and effect relationship. According to the calculations, the cost per patient index was what resulted in the increase in the size of the VISTA database, and thus the improved productivity was what caused the increase in IT investment, not vice versa. This new method of estimating the business value of IT investment may be seen as superior to previous methods because it relies on objective data rather than speculation. Additionally, after a series of calculations, this method allows the researcher to figure out if IT investment did in fact lead to an increase in revenue. Consequently, this process ensures that a calculation of return on investment is meaningful in the context. However, in spite of these advantages, this method also has its limitations. For example, the data required to perform the necessary calculations may not be available. While there are alternative sources to the data, this could alter the results. Furthermore, the analysis is slightly limited by the fact that there are only 3 data points used in the calculation of correlations. If possible, longer data sequences should be considered. And this concludes the presentation on evaluating the value of IT investments. Thank you.